Today we'll be writing the equation of a parabola, um, analytic equation of a parabola. But before we get started, we need to define what what is a parabola. A parabola is a set of points on a plane that are equidistant from a fixed point, the focus, and a fixed line, the directrix. So to define a parabola, we need two objects. We need a fixed point. Here is an illustration of it. We need a fixed point in a plane. Okay, I'm going to call this fixed point focus, the focus. And then we need a fixed line. Okay, that's a fixed line. Okay, this is X and Y. Okay, here is a fixed line. This line is called the directrix. Directrix. Okay, now, based on these two fixed objects that are not moving, this focus is fixed, this line is fixed, we need to find a set of points that are exactly the same distance from this focus to this line. Obviously, here will be a point, all right, because we can approximately highball this to be the focus to this point is the same, the distance of the focus to this point is the same distance from this point to this point, approximately, okay? So now, we need to find other points that when we measure the perpendicular distance from this line to that point will be the same distance to the focus. So we can actually guess around here, over here, that if I measure this distance, is the same as going this way to the focus. Okay, that's one point. We can find another point somewhere over here. So let's say I'm able to find somewhere around here such that the distance here to this line is the same distance to the focus. So I can continue to look for more points, like, find another point somewhere over here that will be the same distance perpendicularly to this line and to the focus will be exactly the same. So let's do geometric marking. Those segments are exactly the same length. So I found me 4 points over here. I can reflect the same thing over here. It will be the same. I can find the same 4 points on the other side, like, the same 4 points. I can continue to do that like that. So in a way, these points, there are many of them. There's so many of them. Actually, they're infinite points like that we can, actually connect them to form a curve. So if we connect all these points together, it's going to form a curve like that. So basically, a parabola is defined by all these points that are exactly the same distance from the focus to that parabola, and then from the parabola to the directrix. That is the first thing that we need to understand about parabola. Okay, so now we're going to use this definition to derive the equation. If we're going to write an equation for this curve, what will be the equation of that curve? So we're going to create some example. Let's say this same curve I just drew, let's assume that here is 0, 2. So that means it's 2 units from this point right here. This point is called a vertex. Let's go back to it. This point right here is called a vertex. Okay, so I'm just going to create example points. That will be, sample points for us. So it will be 0, 2. The directrix must be the same distance from there to the vertex down here. So that means the line, if this is the x-axis, this is the y-axis. That means this directrix will be at y equals -2. Y equals -2. And now we can actually begin to, pick a point along here on this parabola, and we're going to call the point x comma y. It doesn't matter. Let's just pick a point right here that's the same distance from the focus, same distance. We're going to call this point P, x comma y, some generic point. What we know is that if this point will be on the parabola, then this distance to this line, let's call this place D, that distance PD must be the same distance as FP. So FP. That is very important to be able to kind of get your mind wrapped around that. So let me just make a sample parabola that's going that way and going that way, passing through that point. So now we're going to be able to write the equation of this parabola if we make this distance equal to that distance. This distance FP equal to distance PD. So here is how we can do it algebraically. So we're going to say distance FP, well, applying the distance formula, FP, so let's go over here. Distance FP is the same as the square root of x minus 0. We subtract the x coordinates, x minus 0 squared plus y minus 2, y minus 2 squared. Distance PD, this other distance to the directrix, PD is the same thing as the square root x. Okay, well, we need to find this coordinate first of all. Well, it's not hard because we know the y coordinate is -2 for sure. So something comma -2 because that's the y coordinate. Now, this x coordinate will be the same as the x coordinate right here. So it will be x comma 2 will be the coordinate of this point. So now let's form the equation for the distance. So the expression rather. So x minus x will be x minus x squared plus y minus 2. Y, well, this is -2. Sorry about that. So y plus -2, which will be y minus -2. Y minus -2 squared. Okay, so we got the two expressions we need to write the equation of the parabola. From the definition, the distance from the focus to the parabola is the same thing as the distance from the parabola to the directrix. So that means that FP has to be equated to PD. We're going to do that now. We're going to make the two equations the same, the two expressions the same. Let's do that. We're going to say the square root of x minus 0 squared plus y minus 2 squared must be equal to x minus x squared, square root of that, plus y. Now, this is -2 minus 2, so it will be plus 2 squared. There you have it. That's the equation of the parabola. However, it's not neat right now. We just need to clean it up and make it look better. But this is basically what the equation is. But let's try to clean it up by taking square of both sides, okay? Get rid of the square root. It's ugly a little bit. So we're going to take square of both sides. If we do square of both sides, I'm going to copy everything. X minus 0 squared, y minus 2 squared, and then square that big old thing and do the same thing over here. So I'm going to shift up a little bit for you to be able to see all of it. All right, here we go. So now I am going to do the same thing here. Square root x minus x squared plus y plus 2 squared, and square that. The square and the square root are inverse operation. They're going to go away. X minus 0 is just x. So here will be x. Let's just write everything out first. Y minus 2 squared equals x minus x squared plus y plus 2 squared. Now, x minus 3 is just x, okay? And that will be x squared. Y minus 2, we're going to apply binomial expansion. So that will be plus y squared. Y times 2 is 2y times 2 is minus 4y, and then plus 4. That is the expansion of that, okay? Now, x minus x is 0. 0 squared is just 0. That is gone. That is gone, all right? And then this one will be y squared plus 4y plus 4. Okay, this is an equation. We can do whatever we do to the left, we can do to the right. First of all, I see that this y squared here, we can take it from both sides. So we can take it away from both sides. All right. So we also can take this 4 from both sides. All right. So we're going to be left with x squared. So I'm going to add 4y to both sides. So this is going to go away. So x squared equals 8y. And then if I solve for y by itself, so let's put 8y equals x squared. So y equals 1/8 x squared. That is the equation of that parabola. This parabola that we just drew, that is the equation. Y equals 1/8 x squared. This is basically how to find the equation of any parabola if you are given the location of the focus and the location of the line, the directrix line. We're going to do more examples in the next videos. So I hope this helped a little bit. Thanks for watching.